Hello everyone, my name is Han Shengxiang. This is question 1 of homework 4 in the course Probability and Stochastic Process. In this question, we want to find and draw the distribution function of y and the density function of y in terms of the distribution function of x and density function of x. In this question, y equals to gx is equal to when x below 0 is equals to 2, and when x is from 0 to 1 is equal to 0, and x from 1 to 2 is equal to -1 plus 1, and when x is over 2 is equal to the -1. So, and there is a graph of f density function of x and the distribution function of s, and we could according to this, and we could graph the gx and in this graph we could find that when x is below to 0, the y is equal to 2, and when x over from 0 to 1, y is equal to 0, and when it is from 1 to 2, the y is equal to -1 plus 1, and when x is over 2, the y value is equal to -1, and we could use this graph to compute the probability of y, and in y is equals to -1, the probability of y equals to -1 is equals to probability x over 2. So it is equals to 1 minus the distribution of x in value 2, and when in y is equals to 0, the probability y equal to 0 is equal to x from 0 to 1. So it is equals to the distribution x in the value 1 minus the distribution function of x in the value 0. And when the y is equals to 2, the probability of y equals to 2 is equals to the probability of x is below 0. So it's equals to the distribution function of 0. And but in from 1 x from 1 to 2, the y value is from 0 to -1. It is the line, so we want to compute this. The probability in the interface from -1 to 0, y is equals to -x plus 1, and the density function of y is equals to, we could use the function that the density function, it is equal to the density function of x over the derivative of gx and the absolute 8, and it is equals to the density function of x in the value 1 minus y, and over to -1 the absolute, and it is equals to the density function of x in the value 1 minus y. So we summarize this, we could compute that the density function of y is equal to 1 minus the distribution function of x in value 2, and times the delta y plus 1 because it is the y equal to minus 1. And when y is from minus 1 to 0, it is equals to the density function of x in the value y minus 1. And when the y is equal to 0, the value of density function of y is equal to the distribution function of x in value 1 minus x in value 0 and times the delta y. And when y is equals to 2 and it is equals to the distribution function of x in 0 and times the delta y minus 2. And for otherwise, the value is equal to 0. So this is the density function of y. And to compute the distribution function of y, the distribution function of y is equals to the integral of density function of y. But the many of these are just one value, so we could compute it. It is a function, so we could compute this as special in y from 1 to 0. The density distribution function of y is equals to the probability of bigger y smaller or equal to small 1, and it is equal to the probability of y minus x is smaller or equal to smaller y, and it is equals to the probability of x bigger or equal to 1 minus smaller y, and it is equal to the 1 minus the probability of x small or equal to 1 minus smaller y, and it's equal to the 1 minus the density function, distribution function of x in the value 1 minus y. So we could compute this as the distribution function when y from minus 1 to 0, and we could compute that is equals to equals to 0 when the y is below the minus 1, and when y from minus 1 to 0, it is equals to 1 minus the distribution function of x in 1 minus y. And when the y is from 0 to 2, it is equals to the value of 1 minus the distribution function of x in the value 0. And when the y is over 2, and it is equals to 1, so that's the distribution function of y, and we want to draw the distribution function and the density function. And in the distribution density function, we could find that in the y is equal to minus 1, it is the impulse signal like this, and it is equals to 1 minus the distribution function of x in value 2. And from minus 1 to 0, it is a function of x, and in this function we could find the x in the 1 minus y, and it is to use this, and we could find it is just a curve, And when y is equal to 0, it is also an impulse. The impulse value is equals to distribution function of x in value 1 minus the value in 0 and times the delta y. and there is also other impulse in y is equal to 2. It is equals to the value of distribution function of x in value 0 and times the delta y minus 2. So this is a graph of density function of y, and we could use this formula to draw the distribution function and when y is below -1, it is 0, and when the y is from -1 to 0, it is the value of 1 minus the distribution function of x in the value 1 minus y. And we could look at this picture graph and we could use it to compute. It is like a curve, and in the in the intercept of from 0 to 2, and it is value of 1 minus the distribution function of x in value 0. So we could draw it as 1 minus the distribution function of x in value 0 and over 2. When y is over 2, the value is equals to 1. So this is the graph of distribution function, and this value is 1 minus the distribution function of 2. Yes, so this is the distribution function of y.